freshwater streams, and we're going to start off by talking about the headwaters of the stream. There are different zones where that characterize a stream. The headwaters or the source zone, the transition zone, and then the floodplains. Now the headwaters, they actually begin in different areas or from different sources. Some rivers are glacier fed or glacial fed. The Yangtze River in China, which is the third largest river system in the world, is actually fed by the glaciers from the Himalayas, while the Nile River and the Mississippi River are actually spring fed. So major river systems can be either glacial or spring fed. But a large volume of water that actually gets into the rivers actually comes from surface runoff. They're not from one individual source. And so as you move downstream, the characteristics of the river actually changes depending on the type of surface that the water is actually running off. And here's just a couple of diagrams. The one on the left is the Nile River starting down in Lake Victoria, which is actually not although it's the official source of the Nile River, there are actual streams that feed into that lake as well. And similarly, the Yangtze River, with its origins in glaciers, and while it heads predominantly from west to east as it dumps into the Pacific Ocean. Now, as we mentioned, there are three different zones, two rivers: the source zone, transition zone, and the floodplain. And you can think of it in terms of the nutrients and the speed of the water. At the source, you're going to have the coldest water, particularly if it's if either whether it's spring fed coming up from the ground or whether it's glacial fed, it's going to be cold water. And because it's cold water, it's going to have a lot of dissolved oxygen in it. Colder waters can hold more dissolved gases in them, and so at that source, you're going to have large amounts of oxygen. It's also going to be swift flowing, or tend to be swift flowing, as it makes its way to the transition zone. Through the transition zone, it's going to become a little bit more turbid because it's getting some of the water from the runoff from the area around, and from that runoff, you're going to be getting more sediments, etc. It's going to start to warm up simply because it's exposed to the sun and it's no longer, on the glacier or underground. And because of that, it's simply going to have less oxygen. Now, it'll also have less oxygen because you're going to have more organisms living in there, respiring, and they're going to be taking some of that oxygen out of the water. But a lot of it has to do also with the increase in temperature. And by the time you get to the floodplains, the water is going to be slowing down. The rivers start to spread out. Because of that, they're shallower, they're going to become warmer, there's going to be less dissolved oxygen in them. Although in those zones you're also going to have larger amounts of photosynthetic rates, so it's going to at least continue to supply oxygen for the organisms that are there. And because you have different temperatures and different amounts of oxygen, you're going to have different fish species living in the different zones. So once again, here's your source zone. In this graphic, is coming from glacial melt. Through the transition zone, again, you're going to have a change. Usually, well, throughout all of the life of the river, you're going to have a change in elevation, and it's going to make its way to the floodplain where things flatten out. The sediment starts to deposit all the way out to the river delta, and the river delta occurs because as the river brings sediment down, which includes silt and clay, once it hits the ocean, the ions in the ocean interact with the water and force it to dump the sediments at the mouth of the river. So that's where you get your delta. You're also going to be getting your marshes in those areas because the river is going to be slowing down. It's going to be mixing in with the salt water. You also can get some different types of features, oxbow lakes, which we're not going to get into a lot, where the river used to flow over in that area and some of the water simply got trapped as that part of the river was cut off from the rest of the river. But at any rate, that gives you an idea of some of the different characteristics of a river. Now, Rivers are often managed by people where they build dams on them, levees, etc., etc. And a lot of this is to control against flooding, particularly along the Mississippi River, where you have tremendous flooding, but you also have tremendous growth of population, and they have an economic need to prevent flooding. So you have a lot of levees and dams to help do that. But in doing so, when you come up to a dam, the sediments end up dropping and settling to the bottom of that dam, and then it's just the water that flows over the top. Well, if those sediments cannot get down to the delta, down to the mouth of the river, then whatever sediments are there are going to be eroded away by the rest of the water that's there, and so therefore you're going to get an overall lowering of the delta, and that's actually what's happening down in New Orleans, where the land is actually starting to sink. It's not being replenished by the sediments coming downstream from the Mississippi, and so therefore are starting to sink into the ocean. You also have issues with rising sea levels. As it turns out, about 45% of the people worldwide live along the coasts. And because of this, you have a real issue with rising sea levels impacting people. And obviously, here's a picture of New Orleans after Hurricane Katrina. All of this, I don't say all of this, it's near sea level, but it tends to be protected by the levees along the Mississippi River. But once those levees are breached, the water is just going to simply move into those low areas. By the way, if the ocean levels rise about 1 meter, which is 3 feet, the area in red here are areas that will be underwater, under the ocean, under the Gulf of Mexico. And so if you notice, New Orleans will be under the Gulf, as will be many other coastal communities. And that's also not only going to affect people, but then you also have the organisms that live in the marshes, the saltwater marshes and wetlands in those areas. Well, they'll now be completely submerged underwater. Okay, now, so in terms of rivers, those are lotic systems. Some other lentic systems now would be an inland wetland, and those include marshes and swamps and other types of classifications, but that are predominantly differentiated by plant life. Marshes will tend to be grasses, or in fact they're characterized by grasslands, where swamps are going to be characterized by woody plants like trees and bushes and those types of things. These are going to be areas that are either covered with fresh water all the time or at least part of the time. And when we say part of the time, sometimes they may have years that they don't have water, but they're still dominated by the grasses and the trees that can survive under those submerged conditions. They're really, really important ecosystems because, again, they, like other aquatic ecosystems, are going to be filtering and degrading our toxic waste. They can actually chew up a lot of the material that we put into them, or some of the material that we put into them. They reduce flooding. It's a catch basin for water to go, which means since the water has a place to go, it's going to prevent erosion in other areas. It's going to help replenish streams and recharge groundwater aquifers. Oftentimes, there are as the wetlands are flooded, then the water can percolate down through the soil below them and replenish those aquifers below. Because they are highly productive area, they do have a tremendous amount of biodiversity, but they also provide us with food, timber, and recreation such as fishing or other types of catch. And here are a couple of pictures. The picture on the left would be typical of a marsh. It's a grassier area with a nice picture of a white egret in it. And the picture on the right is going to be a swamp that's characterized by woodier plants. But of course, as all ecosystems on Earth, we are threatening these ecosystems by our developments. And because of this, we're going to be having some issues regarding, with ecological services and with economic services as well. As it turns out, we restrict the flow of about 40% of the world's largest rivers. In terms of irrigation, we are over irrigating every major river system, and most major rivers do not actually reach the oceans anymore, which violates the nutrient cycling law. The fact that water is supposed to be able to make its way back to the ocean, that's not actually happening. Cities and farms are polluting our waters. From cities, you have salt that washes off the roads, organics in the form of oils and gasolines and those types of things that wash off the roads, acid rain that falls from the nitrogen oxides and sulfur oxides that come out of our cars, or the coal burning plants that will fall back into the watersheds and eventually make their way into the waterways. Farms, predominantly nitrates, phosphates, that wash off of those. If you recall our conversation on the Chesapeake Bay has been polluted by, among other things, nitrates and phosphates, which create huge algal blooms, which eventually die decomposing, cause the apoxia or hypoxia zones. And then many of the wetlands have been drained for farmland. Most of them get drained for farmlands. And in fact, Iowa, 99% of their wetlands have been lost as they've been creating farmland. So all of this is important because water, whether it's saltwater or freshwater, accounts for 3/4 of our Earth. And because of the tremendous amount of ecological and environmental services they provide, these are things that we need to monitor, manage, and be concerned about. We are threatening all of our aquatic systems. And just to kind of bring this all together, I think in terms of the coral reef, in terms of the three principles of sustainability. They thrive on solar energy. The algae that it lives in symbiotic relationship with the polyps photosynthesize and provide the energy for those polyps. The polyps participate in nutrient cycling as they sequester carbon from the water to produce the coral themselves. The algae recycles nitrogen and phosphates, among others, as they undergo photosynthesis. And because of the environment that they've created with the coral, they create habitat for a tremendous amount of organisms, and the biodiversity level is very, very high in these areas. You have to remember, in nature, everything is in fact connected. That concludes Chapter 8.